Hello friends, welcome to our next lecture on integration by partial fractions. Okay, so in this lecture what we are going to do is three types of functions. The first function looks like this. This is called type 1. It is 3x plus 2 divided by x minus 2 into x minus 3. In the second type we will have 3x plus 2. Okay, look at the same function, both are same except for one difference. This function is a linear one. Here I've used square. I've made this a quadratic function into another linear, so this becomes a cubic. This is a quadratic. Okay, numerator is linear. So notice here, numerator linear, denominator quadratic, numerator linear, denominator cubic. Here numerator quadratic, denominator cubic. So that's how we have our functions designed here. Okay, so these are the types of functions we are going to do. You're not going to get a difficulty level of higher order. That is, you're not going to get cubic by cubic, or you're not going to get quadratic by quadratic, and so on. This will be the maximum difficulty level. These are the three types that you will get in the examination. Okay. Now, when are we using partial fractions? Let us look at the functions. Okay, so like I told you, you don't have the quotient rule in integration. So since you don't have quotient rule, we need to have another method of solving it. Quotient rule is when we have division of two functions. Division of two functions here also. Division of two functions. In these situations is when we use integration by partial fractions. Okay. So let us look at the first one. How are we going to solve type 1? Okay, in type 1, let me write the question once again neatly. X minus 2 into minus 3 multiplied by a dx. Okay, so in this function, what we will do is we'll be splitting this function into two parts. I'm going to, without the integral symbol, let me just write it. 3x plus 2 divided by x minus 2 into x minus 3. This is equal to a by x minus 2 plus b by x minus 3. Okay, where a and b are constants. Where a and b are constants. Okay, so here, why do we split it like this? When I take LCM, what happens is I get x minus 2 and x minus 3 here in the denominator. Numerator will be nothing but a into x minus 3 plus b into x minus 2. This is what we have. And on this side we have 3x plus 2 divided by x minus 2 into x minus 3. Okay, so both the sides I'm going to cancel this x minus 2 and x minus 3. So what I'll be left with is 3x plus 2 is equal to a into x minus 3 plus b into x minus 2. Now see, what I have done here, I have split it into two terms. When it is a linear in the numerator and denominator is product of two linear functions, then we can do this. Okay. So now when we expand this, or rather we should start assuming values for x. Let x is equal to 3. Suppose I take the value 3 for x. What happens? Here it becomes 3 minus 3 is 0. So a into 0 is 0 plus b into 3 minus 2 is 1 here. On this side 3 3s are 9. 9 plus 2 is 11. So the value of b we get as 11. The value of b is 11. Now we need to find the value of a. How do we find that? Again we assume let x is equal to 2 because 2 minus 2 will become 0. So a will be 2 minus 3 is minus 1 plus b into 0 is 0. This is equal to 3 2s are 6, 6 plus 2 is 8. Okay. So now a value will be nothing but minus 8. Okay. A value will be minus 8. So we have the value of B, we have the value of A. Now what happens next is we just go back to the original here. This is the place and we substitute this. So let me show you here so that it is easy for you to follow. Okay, the question, this was the question, correct? This was the question, and this question I've split it into two terms. So now that I've got the value of A and B, I'm going to split it like this. A was minus 8, right? So minus 8 dx divided by x minus 2 plus integral 11 dx divided by x minus 3. Now 8 is a constant, keep it as it is, don't worry about it. X minus 2 will become log of x minus 2. This is mod symbol. We always use the mod symbol whenever we take it into logarithm, okay, into log. And here also integration of 1 upon x minus 3 is log of x minus 3. So all this plus k. So all this you will be adding plus k to this. So these are questions that I have taken from your solved examples in the textbook. So these are not your questions that I have from the exercise. So I'll give you a few problems from the exercise to be solved on your own. Okay. Let's go to type 2. This is your type 2. Integral 3x plus 2 divided by x minus 2 the whole square into x minus 3. Let's see what to do in this case. Okay, let's go to type 2. Okay, so let's go back to type 2 now. In type 2, what we did was a similar question where it is integral 3x plus 2 but with a whole square. So let's see what to do there. 3x plus 2 divided by x minus 2 the whole square into x minus 3. This is what you have into dx. So whenever you have a term, whenever you have something like this, whenever you have a quadratic and then a linear, you have a cubic and you have a linear on numerator, what we will do here is, we'll say that 3x plus 2, the whole thing divided by x minus 2, the whole square into x minus 3 is equal to, okay, there will be one term with divided by x minus 2 plus one term with divided by x minus 2 the whole square, and there will be another term with only x minus 3. So we'll have three constants a, b and c. So we'll have three constants a, b and c. Okay. So now what we will do next is, again take LCM like how we did in the previous case. When we take LCM, we'll get x minus 2 into x minus 2 the whole square into x minus 3. Your left hand side will remain as it is. There is no change in that. In your right hand side, this will become x minus 2 the whole square into x minus 3. In the numerator, you will have a into, there is an x minus 2 and then x minus 3. And in the b term, you will have only x minus 3. And in the c term, you will have x minus 2 the whole square. Okay, so this will be x minus 2 the whole square, what you will have. Now next step is these two terms will get cancelled and then you will be left with only 3x plus 2 is equal to a into x minus 2 into x minus 3 plus b into x minus 3 plus c into x minus 2 the whole square. So only differences in the previous type 1, you had only three constants a, b and c. In this you have, you had only two constants there, a and b. In type 2 you have three constants, a, b and c. Okay, so now we will say let x equal to 2. We said 2 and 3 in the previous one and we found the value of A and B. Here again, to find the value of A, B, C, we'll see 2, because this, when we say 2, 2 minus 2, it will become 0. Again, this will be 0. Only this will be left. So 2 minus 3 is minus 1. So it is minus B is equal to 2 3s are 6. 6 plus 2 is 8. So your B value is minus 8. So there A was minus 8, here it was minus, B is minus 8. Now many of you may have this doubt at this juncture, that what if I say A by x minus 3, B by x minus 2 and C by x minus 2 the whole square, or I interchange in any other format, what happens? Would I still get the same answer? Yes, the final answer will be the same however you may interchange, because now I'm getting B value as minus 8. So suppose I take C divided by x minus 2 the whole square, then C would take the value minus 8. In any case, the final answers when A, B and C vanish, the final answer will be the same. Okay, next. Let x equal to, instead of 2, I will take 3 now. Okay, when I take 3 here, again this term will vanish, this will vanish, this will be 3 minus 2 is 1. So C is equal to 3 3s are 9 plus 2 is 11. So C value also I have got as 11. Next, now I can't take 2 and 3 because both have taken. I should take some other value, let's say some easy number, let's say a 0. Okay, so when I take 0, this will be minus 2 minus 3. Minus 2 into minus 3 is how much? Plus 6. So what you will get is a 6a plus, here it is 0. So minus 3 into minus 8 is plus 24. Here you are taking 0. 0 minus 2 is minus 2. Minus 2 the whole square is 4. 4 into 11 is 44. On this side, 3 into 0 is 0, plus 2 is 2. Okay, so bring these two terms to the other side. 24 plus 44 is 8, 68. When you bring 68 here, you will get minus 6 is equal to 6a. So a is equal to minus 11. So now we have the value of a, b and c. Okay, so we will be substituting it in this. So let us do that. Integral minus 11 dx divided by x minus 2 plus b value. B is integral 8 dx divided by x minus 2 the whole square plus integral 11 dx divided by x minus 3. Now this is what we have. Now what happens after this? This and this we integrated in the previous question also. So this is minus 11 log of mod of x minus 2. Here it is plus 11 log of mod of x minus 3. Right? Now coming to this. This is minus 8 is a constant. Keep it as it is. When you take it to the numerator, this will become x minus 2 the whole power minus 2. Correct? So this becomes something like this, dx. Now when you integrate this, what happens is it becomes x minus 2 the whole power minus 2 plus 1. Minus 2 plus 1 divided by minus 2 plus 1. So I'm just going to write that answer here. Minus 2 plus 1 is a minus 1. So minus 1 minus into minus becomes a plus. And this power, it will become minus 1. So this comes to the denominator. It will become x minus 2. So this is our result of type 2 type of partial fractions. Okay. So don't forget to add k to every answer. Now shall we go to type 3? Let's go to type 3. Let me go back and take down the question. 3x square 3x square minus 2x plus 5 divided by minus 2x plus 5 divided by x minus 1 into x square plus 5. Let me just check once. X square plus 5, x minus 1. Now what do we do with this? See, here you need to note that this term is a quadratic term. This is also quadratic. So in these events, how we write it is 3x square minus 2x plus 5 divided by x minus 1 into x square minus, plus 5. I'm just writing this as it is. This whole thing is nothing but, I'm going to say this is nothing but a by x minus 1. Linear term, don't worry, write it as it is. The quadratic term, write it like this. Bx plus c divided by x square plus 5. Okay. Only then when you multiply, here you will get a quadratic. This when you multiply also will become a quadratic. That is the reason behind writing it like this. Okay. So next step is to take LCM. When you take LCM, the left hand side remains as it is. X minus 1 into x square plus 5. Numerator is 3x square minus 2x plus 5 is equal to x minus 1 into x square plus 5 a into x square plus 5 plus bx into x minus 1 plus c into x minus 1. I'm just splitting it and multiplying. Now cancel these two terms on both the sides. We are left with only this on the numerator on both the sides. Now next step, let's say let x equal to 1. As usual, we need to assume a number which will help us in getting a term cancelled. 1 minus 1 0, 1 minus 1 0. So these two terms become 0. So this term will be 1 square 1 plus 5 is 6. So 6a on the right side, left side. 3 minus 2 is 1. 1 plus 5 is 6. So a value is 1. You have the value of a as 1. Next, let x equal to, let's assume some other easy value. Let's say 0. Okay. If I say 0, this will become 5a. 5a plus this b will become 0 completely, plus c will be minus c. So minus c. On this side you will have 0, 0, 0, 0. So only 5 will be remaining. Okay. We know the value of a is 1. So 5 minus 5 will become 0. So c will be, the value of c is 0. Okay. C is taking a value of 0. Then next, let us find the next value. Let x equal to, we have taken minus 1, we have taken 0 now. What else can we take? If I take the value 1, again these two terms will get cancelled. Now I need to find the value of b. So we can take the value 2. When I take 2, it becomes 2 square. 2 square is 4. 4 plus 5 is 9. 9 into 1 is 9 plus, to find b, 2 into 2 minus 1 is 1. So 2b plus 2 minus 1 is 1 into c. C is anyway 0. So this side 2. 2 square is 4. 4 3s are 12. Okay. 12. Write it, otherwise we may forget it. 12 minus 2 2s are 4. So what you get is a minus 4 plus 5. Okay. So 12 minus 4 is 8. 8 plus 5 is 13. 13 minus 9 is 4. So your 2b is 4. So b is 2. So we got the value of b as 2. We got the value of a as 1. We got the value of c as 0. So now let us go back and substitute. Integral dx, a is 1, no? So dx by x minus 1 or x plus 1. What was the question? I forget it now. It was x minus 1. bx plus c. Let's write that down next. Plus integral bx. What is b? b is 2. So 2x dx by x square plus 5. c is 0, so I'm not even considering that. Now if I have to integrate this is very straightforward. It is log of x minus 1, and in this also you see I have given you a formula earlier. This is your f of x and this is your f dash of x. So when we have f dash of x divided by f of x, the answer becomes, sorry, so the answer becomes, for this the formula is log of x square plus 5. So here I can say plus log of x square plus 5 plus k. Okay, now depending upon the options you can further simplify. This is log m plus log n. You can write it as log mn. It totally depends upon how the options are. Now I don't have the options here with me, so you can look into the options and then solve this. Okay, so we have done partial fractions now. So for self practice you will be doing these problems. Question number 17 and question number 49 from exercise 8b. Okay, so see you all in the next video.